right, and finishing up the explanations for this worksheet here. So number 16, 300 people enter a raffle in which 4 different prizes are to be awarded. And so that is the important part there. The prizes are different. We don't know what they are, but because they're different, we know that there is a distinction, that one is probably better than another, or it's worth more than another. You know, one might be a big screen TV, one might be a, laptop computer, one might be a $25 gift card to a restaurant, but they're all different. And so there's something about them that will make them be that way. So order in this case, turn off the highlighter. Order does matter in this case, all right? Now again, we don't want to think of this from the perspective of 300 people. We want to think of this as we have 4 prizes to give out. And if everybody's got their name in the hat, when it comes to awarding prize number 1, there are 300 different items names in the bin. You pull one name out and you say, hey, you won this prize. Then prize number 2 is awarded. There's only 299 names still in this, big bin or whatever. Then 298, and then 297 for the last set of names. So multiplying all that together, 298 and 297, we end up with a whopping 7,938,988,200 different ways the winner could be selected. All right, compare that to number 17, where people enter a drawing and 4 $50 cash prizes are awarded. So notice now there is no difference in the prize, okay? Whether your name is the first one drawn, the last one drawn, or somewhere in between, you win the same thing as everybody else. There's no benefit or difference because you were chosen first versus last. And so this is one where order does not matter. So that's a combination. And again, we want how many people are available to win. So 300 different people could possibly win. We're going to pick out which 4 of those 300 people actually do win. Slightly fewer options, by actually quite a bit, but still a lot. 330,791,175. All right, for number 18, couples planning their reception. The caterer offers 3 breads, 8 entrees, 10 sides, and 5 desserts. And the package they have chosen includes 1 bread, 2 entrees, 4 sides, and 2 desserts. How many ways can they make their choices? So the order in which, again, they pick the items they want, whether they say, hey, we want the fried chicken and we'd like the roast beef, doesn't matter if they say we want the roast beef and we want the fried chicken for the entrees. So we've got a bunch of order does not matter. Okay, but what do we want? We want 1 bread, and we want 2 entrees, and we want 4 sides, and we want 2 desserts. Okay, so we're going to go through. Each one of these is an individual combination based on that category. So when it comes to bread, there are 3 breads available. We're choosing 1. When it comes to the entrees, there are 8 entrees available. We are choosing 2. For the sides, there are 10 different sides. We're selecting 4 of them. And there are 5 desserts available. We're picking 2. And then every time we see an and in here, the and tells us we should be multiplying. Okay, so we want to take 3 times 8, choose 2. Choose 2 times 10, choose 4 times 5, choose 2. All right, and I am getting 176,400. If that's not the number you got, it's not my work that's wrong. It would be that I hit a wrong button. I think I did okay though. All right. Number 19, 32 kids are trying out for basketball. 12 will be picked. how many rosters will include the Smith triplets, Tim, Tom, and John? Okay, so think about, again, first of all, when you put the names on the roster, does it matter what order you list the names in? And you should be saying, no, it doesn't matter whose name is listed first. All these 12 kids are on the team. Okay, so order does not matter. But now tell me who's going to be on the team. And think about it in terms of the triplets. Okay, we're trying to figure out how many rosters include the triplets. So there would be the 3 triplets, and there have to be some other people. 3 triplets is not enough to fill the team. Okay, so then there have to be 9 others that are not triplets. Okay, they're not among the triplets. So again, order doesn't matter, combination. When it comes to the triplets, how many triplets are there? Well, there's 3 triplets. How many are we putting on the team? All 3 of them. And there's our multiplication of the others. So how many other kids that are not the triplets tried out for the team? Well, there were 32 total kids that tried out. 3 of them are Tim, Tom, and John. That leaves 29 kids that tried out that weren't from the triplet, the Smith triplets. And of those 29 kids, we have to put 9 of them on the team so that we have a total of 12 people on the team. That gives us a total of 3,654 different rosters that would exist, assuming that, again, we put all of the triplets on the team. They all made it. All right, and number 20, last but not least, Becky has 9 sites she wants to visit while on vacation in Maine. In how many ways can she arrange her schedule to fit them all in? So again, this is probably going to be a situation where you might think order doesn't matter, but really order does matter, because is she going to want to drive, 50 miles to the first one to basically drive back to exactly where she'd been, turn around and go somewhere else? I mean, you're going to, again, the difference, it could definitely matter in terms of gas and time and so forth. So order does matter in this particular case, and she's going to 9 different sites. So for the first one, she would have 9 choices for what she saw first. And after she sees that site, she'd have 8 choices, and then 7, 6, 5, and that will continue down to 4, 3, 2, 1, which is 9 factorial. 9 factorial happens to be 362,880. And so there are your explanations for the last 5 questions on that practice sheet.